is Mas Soleha binti Awang Rajik and my metric number is A21A2568. So I would like to present about introduction. So statistics, the branch of the mathematics used to summarize, analyze and interpret a group of the number of observation. Next, statistics also have two measures. For the first measure is the descriptive statistic that involve the organization, summarization, and display the data. And the inferential statistics are used to allow and research to infer with the sample to larger population from which they selected. Next, for our objective is to identify type of the data and the variable. Second, to calculate the data using the SPSS software. And lastly, to analyze data with the SPSS, which is as the hypothesis testing, correlation, confidence interval, and prediction modeling.
My name is Wanar Zarifa binti Wan Zainuddin. My metric number A21A3483. I will explain about the description of the data. The data we collected is related to vehicle fuel consumption with a total of 393 observations per 100 per kilometer. Data for our group is consistent: liter per 100 kilometers, kpl, cylinder, horsepower, weight, and car brand. Our group only use 4 types, namely liters per 100 kilometers, kpl, horsepower, and car brand. This data description is used to display concise and quick data for our 150 population data. We sample the data variables with other options. The data we selected from the variable were divided into two, namely qualitative and quantitative. Qualitative variables are categorized as variables that do not involve number or listed as car brand, while quantitative variables are categorized as variables that involve number and can be calculated, such as liter per 100 kilometers, kpl, cylinder, horsepower, and car brand. Therefore, graphic or false were used to present evidence of the data in our study.
Assalamualaikum and salam sejahtera. My name is Nurul Aina Suha binti Reza. My metric number is 21830425, and today I want to present a numerical descriptive measures set A. Measuring of the central tendency mean, median, and mode. The formula mean is x equal to total x divided by n, where the total x is sum of all the data x, n is the number of the data. For example, the liter per 100 mean is total all the data. It have 150, and the answer have in total 931.50, and the mean of the liter per 100 is 6.21. Median for the median formula is m equal to t n plus 1 divided by 2, where the t is the term and is the number of data. For example, in data set A, I have to be arrange the data from the smallest data to the large data and search the position by dividing data 150 to by 2 and search the data. And the answer for the liter per 100 is 9.25. For the mode is value of the most often used set of the data. For an example, liter per 100 is 7.969 meters. Group data with class labels. Mean. Formula mean is a sum of fx divided by n, where f is the frequency of the class, the midpoint of the class, fx a number of the interest in the sample, class interval, midpoint, frequency, and fx. The total data in the set A is 150, and for the liter per 100 is 879, and the answer is for the mean for the liter mean is 5.86. Median. Formula for median m is Fm. And m plus n divided by 2, sum of Fm minus 1 and divided by Fm, and multiplied by C, where the Fm is the lower class boundary of a median class, Fm is frequency of a median class, sum Fm minus by 1 is cumulative frequency before median class, C is the class wide. For the example for the set A, for the liter per 100 sample is answer is 5.7700 liter. For the mode is where element is lower class boundary of the model class. Triangle 1 is the difference between the frequency of a model class and the frequency of the class before the model class. So triangle 2 is difference between the frequency of a model class and the frequency of the class in model class. And C is class 1. Measure of the position range first quarter and third quarter and intra-quarter range. A, the range formula is large value of the data minus by smallest value of the data. For example, the liter per 100 is 11.11 is the largest value of data minus by 2.63 is the small value of data. The answer is 8.880. For the first quarter, the formula is value that divides the value of the data that less than the median into equal parts. For the example, the in quarter meter 100 is 100 is the data plus 1 and divided by 4. The position is 27.75 position. And the answer for the first quarter by to the liter per 100 is 5.03. Third quarter is the value that divides the value of the data that greater than the median into two equal parts. For example, the liter per 100, the position is 113.25 position, and the answer is 7.15 meter. And the formula for interquarter range, the third quarter minus the first quarter. The liter interquarter range is 2.11 meter. Grouped data with the class intervals. Range. The formula for the range is midpoint of the highest class minus by midpoint of the lowest class. For the example, if the range is midpoint of the highest class is 11.5 and the midpoint of the lowest class is 1.5, and then the answer is 10. For the first quarter, it is where the first quarter is lower than Q1 is the lower boundary of the Q1 class and is the sum of the frequency F is cumulative frequency just before the Q1 class, and Q1 is a frequency of the Q1 class and C is class of the Y. For example, in the say data is answer for the liter per 100 first quarter is 81.2 liter. Third quarter formula where the LQ3 lower boundary of the Q3 class and the sum of the frequency F is cumulative frequency just before the Q3 class and F Q3 frequency of the Q3 class and C is class of the Q3 class. For the example, for the NZA is the third quarter per liter per 100 is 8.04 liter. For the formula into quarter range is third quarter minus by first quarter. In the quarter range in liter per 100 is 8.04 minus by 21.2, and the answer is minus 73.16 meter. Measures of the variance, and the standard deviation. The variance formula is as power of 2. The n divided by n plus 1, the sum x power of 2 minus by total x power of 2 divided by n. For the variance liter per 100 is variance 2.5 liter. So standard deviation formula for is square root, the same as the variance formula in the side, and the example for the liter per 100 is square root 2.12 and the answer is 1.4 liter.
Hello Dr. Tan, my name is Nur Syahira Izzati binti Muhammad Syahirul Akmal A21A2897 and I will continue with graphical presentation. This is the table of histogram for the liter per 100. This is the histogram for liter per 100. The midpoint of class 5 to 6 interval is 5.5 and has the highest frequency of 77. The midpoint of class 7 to 8 interval, which is 7.5, has the second highest frequency of 41. The midpoint of class 11 to 12 interval is the highest midpoint of 11.5 but only got 1 as the lowest frequency. Midpoint with a class interval of 1 to 2 get the same frequency as the class interval of 11 to 12 but has the lowest midpoint of 1.5. This is table of histogram for KPL. This is histogram for KPL. The midpoint of the class interval 14 to 18 is 16 and has the highest frequency of 76. The midpoint of the class interval 19 to 23, which is 21, has the second highest frequency of 33. Midpoint of the class interval 34 to 38 is the highest midpoint of 36 but only got 1 as the lowest frequency. Class interval 29 to 33 has the same midpoint with a frequency of 31. This is the table of histogram for cylinders. This is a histogram for cylinders. Midpoint of the class 6 to 9 interval is 75 and has the highest frequency of 141. Midpoint of the class 2 to 5 interval is the highest midpoint of 3.5 but only get 9 as the lowest frequency. 9 to 6 class interval get the highest frequency and midpoint in the above histogram. This is the table of histogram for horsepower. This is the histogram for horsepower. The midpoint of the class 0 to 1 interval is 0.5 and has the highest frequency of 141. The midpoint of the class 2 to 3 interval is the highest midpoint of 2.5 but only get 9 as the lowest frequency. This is the table of histogram for wake. This is the histogram for wake. Midpoint of the class 2 to 3 interval is 2.5 and has the highest frequency of 92. Midpoint of the class 4 to 5 interval is the highest midpoint of 4.5 but only get 58 as the lowest frequency, while 4 to 5 class interval get the highest frequency and midpoint in the above histogram. This is pie chart for brand. Honda brand has the highest frequency of 40. Second highest frequency is the BMW brand of 39. Third highest frequency is Ford of 34. Datsun brand has the lowest frequency of 1, while lowest frequency is Citroen of 2. This is pie chart for brand record. Honda got the highest percentage of 26.67%. Second highest was BMW at 26%. Ford car brand got the third highest at 22.67%. The lowest brand record is Datsun, which is 0.6%, while the top is Citroen.
Assalamualaikum warahmatullahi wabarakatuh. My name is Naamira Izati binti Abdul Rahman. My metric number is A21A2788. I will continue my part, which is statistical analysis using software SPSS. Numerical descriptive measure SPSS. For example, to get the answer above from the SPSS, we have to find the all mean for liter per 100 to form total mean and use the total mean to get the mean, median, mode. According to the table, the mean is 6.2100, the median is 6.2500, and the mode is 7.69. This distribution of shape for 5 variables, which is liter per 100, kpl, horsepower, weight, and cylinder. And D is a measure of variation for 5 variables, which is liter per 100, kpl, horsepower, weight, and cylinder. For example, the variance for liter per 100 is 1.966 and the standard deviation is 1.40201. According to the table that illustrates the measure of variance that our group discovered in SPSS. ANOVA is a statistical method that extracts the observed variance data from the various components to be used for additional experiments. A one-way ANOVA is used by 3 or more data classes to collect information on the relationship between dependent and independent variables. Correlation analysis. Based on the Pearson correlation analysis by using in SPSS, we determine the relationship and strength between the variables by measuring them. When change in one variable tend to be accompanied by constant change in the other variable, this is called a relationship. During this study, we measure the correlation between liter per 100 kpl, cylinders, horsepower, and weight. Model summary. The R-square value is 0.464, which means 68.1% of the variation of weight. The adjusted R-square is 46.0%. This is catastrophic metric for liter per 100 kpl, horsepower, and weights. Confidence interval. Confidence interval is a range of value with which the population parameter is supposed to exist. The 95% confidence interval can be related to B confidence level. Based on the result of the descriptive output table above, there is 95% confidence interval for mean confidence in liter per 100 has been calculated. The lower bound and the upper bound are 5.9838 and 6.4362 respectively. Also, it represented the standard error for this dependent is 0.11447. In the result, it can be said that we are 95% confident that the mean score for confidence in liter per 100 was fall between 5.9838 and 6.4362. Prediction modeling. This is test of normality and model summary. The R-square value is 0.545, which means 33.8% of the variance can be explained by liter per 100. The adjusted R-square is 54.2%. ANOVA. The p-value from the ANOVA table is less than 0.000, which means that at least one of two variables liter per 100 and weight can be used. Coefficient. Based on the coefficient table, refer to the column y equal 2.011 plus 0.291 plus 1.872. From the multiplied regression equation, B is 2.011, a constant or intercept y which reflect of weight at each location. Next, by refer the parameter for year, which is 0.291, while by refer the parameter which is 1.872. That's all. Thank you. Okay, so this is the conclusion remarks, and we have two branches of the statistic. First is descriptive statistic and inferential statistic. And our group also use random sampling with 333 observation, and we are also use only 150 cases. Then using this sample, we were able to identify some of the components that we study. Next, for our graphical, we are using the chart histogram, pie chart, and OGIF to show the frequency about the vehicle fuel consumption. And next, this is also we can conclude that we know about the statistical calculation based on the data. So thank you.